What's up, Algebra 2 students? This is lesson 22. Our objective is, how do you solve equidistant problems and similar triangles with proportions? So we're going to start off with these equidistant problems. But before we start these, you just need to remember that if we multiply a rate times time, we'll end up with a distance. So let's say 30 miles per hour times 2 hours. Those hours would reduce. We say 30 times 2, you end up with just miles, so it would be 60 miles. So rate times time equals distance. Just kind of remember that as we work on these word problems. This says Elvira made a trip on Tuesday, and David made the same trip on Wednesday. Now let's stop right there for a second. Since Elvira and David made the same trip, doesn't matter what day they went on, it just matters that they made the same trip. So that means their distance is the same. So they went from here to here, right? This was Elvira's distance. And then this was David's distance. Point is basically that they're the same. Okay? Elvira travels at 14 miles per hour. David traveled at 21 miles per hour, so his time was 3 hours less than Elvira's time. How far did they go? So really we're just looking for the distance between those two lines, right? How far is it from here to here? That's what we're looking for. So my answer is going to be a distance, of course, in miles, because our rates are in miles per hour. So first of all, let's just set up a quick equation. We know that the distance of Elvira is equal to the distance of David. And then from this equation over here, we know that the rate of Elvira times the time that Elvira traveled is equal to the rate of David times the time that David traveled. Okay. So really I'm just using dr and t to represent distance, rate, and time. Okay. Now let's see if we know any of these things. It turns out that we do. We know Elvira's rate. The rate of Elvira is equal to 14 miles per hour. David travels, so the rate of David is equal to 21 miles per hour. So his time was 3 hours less. So we have a relation here between Elvira's time and David's time. So first of all, we know that Elvira's time is longer than David's time for two reasons. One, they told us it's less than, and for two, we know they went the same distance, but David traveled at a faster speed, so we know that it would take him less time. So let's see if we can write a relation there for this then. We have the time that Elvira spent and the time that David spent. We know that his time was 3 hours less than her time. So if I said her time minus 3 would equal to his time. Or if we wanted to, we could have said the time that Elvira spent was equal to the time that David spent plus 3. So either one of those, it's supposed to be an R there, either one of those last two would be fine. So we have this equation over here on the right, saying that my two distances are the same. I have a couple numbers, and then I have a relation between my two times. So let's just take this information that was given and plug it in right here. So the rate of Elvira is 14, and the time of Elvira is the time of David plus 3. So I'm using this one down here. That should equal to the rate of David, which is 21, times the time of David. So notice now we have an equation, but it only has one single variable in there. So now let's see if we can start solving this. Distributing that 14 is going to be 14 times d sub t plus 42. It's going to equal to 21 d sub t. Subtract that 14 t sub d. It's going to give me 42 is equal to 7 t sub t. So that means the time that David took is equal to 6. And of course that would be in hours. But again, that's not what we're wanting. We're wanting how far did they go. But we do know that if we multiply the time times his rate, that would tell us how far. So what I'm going to do is I'm going to say 6 times his rate, which was 21, and that would equal to 126 miles. 126 miles is how far they went. Just another one like this. Let's try to move a little bit faster. Briar Rabbit hopped off towards the briar patch at 10 kilometers an hour at 10 a.m. At noon, Briar Wolf began the chase from the same point. If he caught Briar Rabbit at 2 p.m., how fast did he run? So again, we know they want both the same distance. Alright, they went from here to here. They both started at the same point, and they both ended their chase at the same point. One of them successfully, one of them unsuccessfully, but still. So this is the distance that the rabbit went, and this is the distance that the wolf went. So we know those two distances would be the same. Remembering that the rate of the rabbit times the time of the rabbit is the same as the distance of the rabbit. And we know that the rate of the wolf times the time of the wolf would equal the distance. But of course, remember, we are looking for how fast did he run, which is the wolf. Okay, so our answer is actually going to be R sub W. That's what we're looking for. So let's see, what information do we know? We know how long. We know their times, because it told us what time they started, what time they ended. And we also know the rate of the rabbit, right? The rate of the rabbit is equal to 10 kilometers per hour. The rabbit started at 10 a.m. and was caught at 2 p.m. So 10, 11, 12, 1, 2, 3, 4. So the time of the rabbit is equal to 4 hours. The time of the wolf started at noon and ended at 2. So time of the wolf is just 2 hours. So let's see if we can use these two pieces to find the distance. Alright? So let's say 10 kilometers per 1 hour. Multiply this by 4 hours. Those hours will reduce and I'll end up with 40 kilometers. So this is my distance. Now since they went the same distance, I know that the wolf also ran 40 kilometers, right? So I could say the rate of the wolf times the time, which is 2, should equal to 40 So solving for r sub w, we divide both sides by 2. And that would equal to 20 kilometers per hour. Alright, enough of that. Let's solve some proportions. Remember, proportions state that two fractions are equal to each other. And remember, if we have two triangles that are similar, then their corresponding sides are what we call proportional to each other. So that's what we're wanting to use here. So we have these two triangles. We see that this angle is the same as this angle. And we see that this angle is the same as this angle, which means then that this angle is the same as this angle. Okay? So let's see if we can set up a proportion here. I'm looking for a side length that we have on both triangles, and I'm seeing that I'm looking for the x and the y here, but I have the 5. So this 5 is across from the blue angle, so the one across from the blue angle and this one is the 6. So then I know I'm going to set up a proportion 5 over 6 is equal to, and let's just go alphabetical, let's solve for the x. So notice this 5 came from the triangle on the right, so I want to keep the other numbers from the triangle on the right on top. So then I'm going to write the x on top. And then I also notice that the x is across from the gray highlighted angle. So I'm going to use the side that's across from the gray highlighted angle, which is 7. And then I'm going to cross multiply and divide and solve for x. So my answer there is going to be 5 and 5/6. Of course, it's only one of my answers because I'm looking for both x and y. So we'll do something similar to find the y value. I'm still going to keep that 5 over 6. Now I'm looking for the y. It's across from red. So I'm going to say y over the number across from the red angle, which is 9. So multiply. 9 times 5 is equal to 6 times y. So this is going to be 45 is equal to 6y. Divide by 6 gives me y is equal to 7.5. And there's the other one of those. Your homework is on page 107. You can do 1 through 15 all, and then 5 more of your choice. Good luck.